Hi, 7th grade Trailblazers. This is our first video this week. You do have two. I did combine a couple of sections from the book together so you didn't have 4 videos to watch, even though they would be like 5 minutes each. I just thought we'd watch 2 and get it over with. So we're going to talk about scientific explanations and scientists and society, and it'll go quick, I promise. There is no homework embedded in it, but you do still need to watch it because it's important stuff. All right, so how do scientists form scientific explanations? And so they do it pretty methodically. They're going to research information. They're going to design experiments. I can't talk this morning. Design experiments, and they're going to make models to form their explanations. They're not just going to say, it happens because of this without any prior knowledge or researching. So explanations describe how something works or why something happens. So the girl in this graphic says, why do sodium streetlights have an orange glow? So just so you know, different types of lights are made of different elements. Sodium is an element on the periodic table, and when electrical current is passed through it, it glows orange, and we'll see that next year when we study chemistry. And the guy says, because the lamps emit light that is orange. That's not really a good explanation. The explanation I gave you is right, because sodium, when electrical current is passed through it, glows orange. That is the correct way. So we have to make sure with scientific explanations that they are actually explaining what we're observing. All right, so how do they form them? All scientists. This is important, no matter the discipline. So the discipline means science. There's lots of different types of scientists. The discipline is what they specialize in. For instance, my degree is in molecular microbiology. Do I know much about ornithology or birds? Probably not, because I didn't specialize in that discipline. In school, you probably have 7 different disciplines that you're studying right now. Science, math, language arts, civics. Okay, so those are different disciplines of school. Well, in each of those big overarching themes, there are smaller disciplines. So no matter what a scientist does, they're going to use the same methods in the way they approach their work. So the first thing we really need to talk about is empirical evidence. Empirical evidence must be obtained for our research or our studies to be valid. So it's all the data and observations that we collect. So all good scientific investigations need to contain empirical evidence. You just can't say, well, the ball bounced a lot, and this rubber ball works better than this rubber ball in bouncing. Instead, you need to give the specific height the ball's bounced, how many times you bounce the ball. So we need to include all that good reporting. All right, to answer questions, scientists began by collecting evidence. So that's what an investigation is, generally in an experiment. Then they're going to analyze it. And why are they going to analyze it? Because they want to make sense of it. This is why, as science teachers, we make you make charts, we make you graph, because that's where you can find the patterns in the data. So if I look at the graphic on this screen, it shows the number of tadpoles. Like if we look in 1990, there was probably 200 tadpoles in this specific pond. We see that it spikes a whole lot in 1992, and then drops rather rapidly in 1993, goes up a little bit, but kind of maintains this steady flow of frogs between 400 and 500. Now, we want to know what that initial spike was caused by. Was it because one of their predators died out? Was there an abundance of food? Like, what happened in 1992 to cause that large spike? So we would have went back and looked at that data from that year to find out what caused that occurrence. Having it graphed like that makes that pattern or that evidence really easy to see. All right, so this is important to understand that scientists interpret the same evidence differently. This happens because of political, social, all kinds of different reasons. So scientists have to evaluate and determine the quality of each other's scientific explanations. In the science world, scientists are always arguing about new theories that another scientist have put out. And this graphic on the right is really interesting. This is this shows what adults, just normal adults who aren't scientists, and how scientists disagree. So GMO foods, you've probably done a little bit of research in elementary school. GMO is genetically modified foods. 37% of adults say they're okay to eat, whereas 88% of scientists disagree and say they're fine. As a scientist, maybe they have different evidence to support their opinion. Humans have evolved. Only 65% of adults believe in that evolution, whereas 98% of scientists do. Only 68% of scientists, of U.S. adults said that, children should have to have vaccines, whereas 86% of scientists do. So I'm not going to continue to read it. You can see, but the difference that even scientists and regular people who are intelligent, who are smart, disagree because we have opinions. And opinions is ideas that we form from evidence, but we haven't really confirmed it either way by new evidence. All right. How do scientists affect society? They do. Huge. Scientists have an effect on society. And on the opposite, society affects scientists. So scientists are constantly trying to make new discoveries. When they discover something new, other scientists thoroughly check their work. They're going to review all the experiments, data, and results. If they get the same results, and then another scientist doesn't get the same results than we get, this is how new ideas are brought out. However, there's a scientist that does an experiment and then I try to recreate it and I don't get the same results, I'm probably not going to believe that other scientist. All right, so however, even though the scientific community confirms a new discovery, it doesn't mean that society accepts it. Sometimes a discovery conflicts with the beliefs of a society. When this happens, a scientist's work can cause controversy or public disagreement between groups. And this has happened all throughout human history. So when we look, if we look at the cartoon, we've got that kind of wizard-looking guy. So there's chemistry and alchemy. Chemistry is science. Chemistry studies how atoms react in the natural world, whereas alchemy was more like magical. How do we turn ordinary objects into gold? The Philosopher's Stone, if you've read Harry Potter. All those things are alchemy, and that's not really based in science. But people, for a long time, believed in alchemy and did not believe in chemistry, and so there was controversy. The next one shows phrenology and neurology. So phrenology was this misguided belief back in the day that the actual bumps from your bones in your skull could dictate or tell what kind of person you would be. That now we believe in neurology. That's the science of how neurons act in our brain. So, there's conflict there. Some scientists believe in phrenology, some believe in neurology. Different groups of people believe in that. Most people today do not believe in phrenology, but back when it was popular, they sure enough did. So we've got magic versus physics, astrology versus astronomy. These are all things that cause controversy between groups of people in society. Scientists can change society, but by defending their work in the face of controversy. So stem cell research is a huge ethical thing that causes conflict right now in these United States. So there's a whole group of people that say, no way, we should not do stem cell research, and they have very valid reasons, ranging from religious, philosophical, moral, to some other scientists that say, hey, we could save a lot of lives if we did stem cell research. So both groups are valid and have valid arguments, but different scientists, based on their own bias, are going to stand behind a specific group. But, more and more talk about it is what changes things. Let's talk about Galileo. So he was very controversial, and we'll hear more about him next year in the 8th grade when we study astronomy. But, so Galileo was this very, very smart dude, and he was around the time that telescopes started coming out, and he got one, and he started noticing all this cool stuff happening with the moon, and he said, for years, and let me back up, for years we believed as a human race that the entire universe was just our solar system, and that all objects in our solar system revolved around the Earth. That's called the geocentric model. And this is what, back then, a lot of biblical and religious texts in Europe backed up. But Galileo said, hey, wait a minute. I'm making these observations, and that geocentric model, it's not supported. Instead, it's really a heliocentric model where all of these objects, they're really revolving around the sun, not the Earth. Well, that caused controversy because he contradicted what leaders of that time were teaching and thought. He got in so much trouble, they banned his books, they put him under house arrest, they pretty much publicly humiliated Galileo because he contradicted their beliefs. Well, now today, we totally know that the heliocentric model of our solar system is what's actually happening. Fast forward a couple years to Ignaz Semmelweis, and he was an Austrian doctor. He helped mothers deliver babies. And he noted, man, these poor babies and moms were dying, especially the babies, dying at a high rate. And he noticed it's because the doctors going between births of delivering babies were not washing their hands. So he said, man, I think they're, spreading infection. So he got the doctors in his hospital to start washing their hands in between delivering babies of different mothers. And they noticed that the mortality rates of the babies dropped, like babies stopped dying. So he decided, I'm going to share this with the rest of the world. This is huge. We can stop having these poor babies die because doctors aren't washing their hands. So he did share his data. But what happened to him, unfortunately, is even though, yes, babies were living more, he lost his job because, he just went against what was a normally held belief. A little more recent, Rachel Carson. So back during World War II, we needed to get a lot of crops so that we could supply our troops in World War II across the seas. So they were in Asia and they were in Europe. So we started using this pesticide called DDT. And this pesticide DDT would help kill insects that would damage crops. So we used it for a long time, since the 1940s all the way up to the 1970s, until there was this scientist called Rachel Carson. And she started linking this chemical DDT to a lot of not only environmental things that were disastrous, but also to some things that were causing harm in humans. The problem is that farmers wanted to keep using DDT. It was great. It killed all these insects. They had all these crops. They were making money. Things were good. And now they didn't have DDT anymore. And so there was controversy and conflict there. But her research did good things. It caused DDT to be banned in the United States, and therefore the environment around these farms was able to get better, which is important. All right, that's all for this one, and I'll see you guys later this week with one more video. Have a great day.